Hi, welcome to this new episode of Understanding Gradle. This is the last episode in my series on Java modularity, and in this one I would like to look at testing in combination with the class path and the module path, which are the fundamental Java modularity concepts as we have learned in the previous videos. Testing in Java projects or with Gradle in general is a topic I already covered in multiple videos. That's where I'll start with a recap of how the class path concept is used in testing Java projects with Gradle. Afterwards, we'll look at what happened if you develop Java modules with the module path concept, which influences testing quite a bit. Because testing in Java traditionally makes the assumption that on the class path all code is visible, which means that your test code can reach into your production code at almost any point. Test frameworks like JUnit partially rely on this, and also certain testing concepts like unit testing may require this kind of open access to everything. As we discussed in the video on the module path, module boundaries and visibility of packages is known to Java at runtime. So at runtime, the access to certain things is much more restricted and might be completely forbidden. That's why in the video today we will explore the different options you have to test Java modules on the module path with a test framework like JUnit 5 and Gradle. And we'll explore what you need to configure in Gradle to get these setups working. But let's start with a traditional class path example to see how the class path related concepts and behaviors explored in previous videos relate to testing. As in the previous video, I use an example with only one module, the app module. But everything we look at then also works in a multi-module setup, like you know from most of the other videos. And still, to be consistent, I'll put most of the Gradle configuration into a convention plugin. First thing to remember is that test code usually is located in the same module or the same project as the production code. By default, it's located in the source test Java folder. In Gradle terms, these folders, source main or source test, are called source sets. The main and the test source set are automatically available as soon as you use any of the Java plugins. And you can add additional source sets, different features we have explored before, like additional test suites, or feature variants, or test fixtures as a specific feature variant, or rely on additional source sets. You can say that each source set can be seen as an isolated subcomponent or submodule, if you will, that is self-contained and does not necessarily need to know anything about the other source sets or the other submodules. Usually though, there is some kind of relationship that's where they are all defined within one module. However, this also means that each of the source set has its own compile class path and its own runtime class path, which are realized in Gradle through configurations in the dependency management sense. The Java plugin already configures tasks to use these configurations as their class path. For example, the compile Java test that compiles the test code uses the test compile class path, which can also conveniently be accessed through the corresponding source set. It is then used internally, as I've explained in the video on the Java compile task, by calling the Java compiler with the class path computed from that configuration. The test task that executes the tests gets the corresponding runtime class path. From this, the class path is computed that is then passed to the Java command to run the tests. The class paths are filled with the dependencies we declared, and as I have shown in the declaring dependencies video and the video on the class path, there are different scopes which are also realized as configurations to define dependencies. The scope will decide if things end up only on the compile class path, only on the runtime class path, or on both. And as there are several class paths in one project, there are also several variations of these scopes, as you can see here when you declare a dependency to some module. For tests, we would, for example, use the test implementation dependency to get access to the JUnit 5 API and a dependency to the JUnit engine, which is only needed at runtime to execute the tests. We see here that a single Gradle subproject does not only have one compile and one runtime class path, but multiple of these depending on the source sets that are registered. And between these class paths, you have the same relationships and potential issues that you also have when you have multiple class paths between several components or several subprojects, as we've discussed in the video on that topic. So to briefly look at these issues again, you may end up with different versions of a library on the test runtime class path than on the main runtime class path if there are different dependencies causing different kind of conflicts. You can mitigate this by using consistent resolution. You may end up with duplicated classes on the test class path only because there's a hidden capability conflict, which can lead, depending on the order of things on the class path, to different classes to be loaded at test runtime than at production runtime. To avoid these kind of issues, also scan the test runtime class path for duplicates, and if there are any, make sure to add capabilities through component metadata rules where they are missing. Once the dependencies to JUnit 5 are added and the test task is configured to use JUnit 5, we can write and run test code with JUnit 5. In my example, I prepared some production code, which is an application class that here for demonstration purpose only prints out the name of the Java module the application is located in. And I've added a test class with a test method that runs this code and prints out the Java module the test code is located in. Right now, we are not using Java modules. Even though there is a module info for our production code, there's none for the test code. Because the test is located in a separate source set, it's like a separate module from the Java module perspective. So it would need its own module info, but we'll get to that in a bit. For now, because the tests themselves are not modules, Gradle will decide to run them with the class path. And if it puts our main application module on the class path, it will just be treated as a traditional jar and the module info will be ignored. So if we run the test, we see that the module name both for the production code and the test code is null, which is expected because, as I just said, the module information is ignored when we run things on the class path. If you don't do Java modules and don't care about the module path and module information in your project, this is all about testing with the class path. As you see, most topics have already been covered in the videos I linked and pointed at. The thing to be aware of is that the test runtime class path will always differ at least a little bit from the actual runtime class path because you add the test framework, like in this case JUnit 5. It's important to be aware of this because, for the reasons I mentioned, it could happen that your test class path differs too much from the runtime class path, so you test something that you don't actually run in the end. So keep in mind that issues like dependency version or capability conflicts or duplicated classes on the class path are also an issue on the test runtime class path. Let's see how we can get the tests to use the module path. The test task, similar to the compile and exec task, will run things with the module path as soon as the module info for the project or the module you are running is available. From the Java module perspective, each source set in Gradle is a separate module. It makes sense because each source set also has its own dependencies, which corresponds to requires in the module info files. And each source set is compiled separately and potentially packaged into a separate jar. And in the module system, as we learned, a jar has much more meaning because each jar represents a separate module with a separate module info. So the most elegant way to do testing with the module system is to treat our tests as a separate module because they are a separate piece of code that's separated from the production code. This is also sometimes called black box testing, which means the modules I test, so my production code module, is something the tests won't look deeply inside, but they would only use the public API of that module to do testing. Concretely, it looks like this, that we need to add a module info Java also to our test source set. Let's do this for example. As you see, the test module has a separate name, which is different to the name of the main module. Because all rules of the module system and the module path apply, we also need to say now for our test module what it is allowed to see and use. Because we want to test our main module, our test module needs to require it in order to see it at all. Then we want to use JUnit 5 APIs to annotate the tests and do assertions. So our test module also needs to require the JUnit 5, also called Jupyter, API. Only with these entries, our test code will still compile and run. Then there's another aspect we need to consider regarding the visibility of packages and classes in modules. By default, a module is so close to the outside world that another module can't access anything within it via Java's reflection mechanism. These mechanisms, however, are used by JUnit to discover the test, so the test annotation you add to the methods. To allow this, we need to open the module. This will allow reflective access for any other module. If for some reason you also want to use that in production code or want to be more selective, there's also syntax to only open up selected packages for reflection and also to only allow reflective access from certain modules to them. Now with our test module being an open module with the requirements to the code we want to test and the test framework itself, we can run our tests again. They compile and run, and we see that now things run on the module path because we can ask for the module names at runtime and get them printed out. And here we see again that our production code is located in a different module with a different name than the test code. There's one issue though with the standard setup in Gradle for this. Gradle by default does not build a jar of the test code, but just passes the folder of classes to the runtime class path of the test. This becomes an issue when you also have resources, so additional text files or data files that you need in your tests, which are normally located in a separate folder. If we add some text file here, for example, we can see in the build folder that the test classes and resources are put into separate folders. These will be passed as two separate entries to the module path. But because on the module path each of these entries is a module, these will be considered separate modules. But of course the resources belong to the classes, and they are also not a complete module because they have no module information. With the setup, if we will try to load the text file in our code, the test fails because it can't find the file because it's not located in the module. To avoid such issues, I would recommend to always only use jars on the module path if possible. For the Gradle test task, this is unfortunately something you need to configure yourself, or you can use an additional plugin. If you do it yourself, you first need to register a jar task that packages your test code and resources into a jar. We already looked at doing something like that in the video on feature variants. So the name of the task and what should go in there is all provided by the source set. You just need to wire it up. And you need to give some unique name to the jar file through a classifier. And then you need to reconfigure the class path of the test task jar instead of the folders. This can be done by setting the class path of the test task to the runtime class path configuration plus the output of the jar task, which is the one jar file. If we run the test now with this adjusted setup, the resource will be found. To simplify this rewiring of the test task, there is another GradleX plugin that we developed. It's called the Java Module Testing plugin, and you can add it to your convention plugins by a dependency to it in the build Gradle file of your BuildLogic project. And if we add that plugin to our convention plugin, we can configure in one line that the test suite contains Java module blackbox tests, and the plugin will do the corresponding reconfiguration for us. The setup we just explored is great if you can test your modules only through their public API. Compared to the corresponding class path setup, it actually reduces the chances that the addition of new modules like JUnit somehow influences the runtime behavior of the application code. Because with this, the module isolation stays at test runtime, while in a class path setup, all classes, no matter if they are production code or test framework code, are mixed into one big bucket, and the runtime can't make a distinction between them. However, this strict isolation causes problems for certain testing approaches, in particular for unit tests, where you typically test such small units of code that these units are not exported to the public API, like for example a protected method or class in an internal package. Let's go back to the example and look at this. One thing you often see in unit tests is that they test something that's not public API. For example, a protected method like the one we have here in the application that prints the module name. Let's assume we would like to test that method directly. We can't do that in our current test class because it can't see this protected method. To make it visible only for the tests, we would need to move the test to the same package as the production code, because inside one package, protected methods can be accessed. And this is quite common practice and works fine on the class path. With the tests in a separate module setup we have here, this doesn't work. Because, you may remember, a package is unique to a module, so we can't have two modules with the same package. And apart from that, the protected method won't be visible anyway to the outside. So for this, we can't do this approach of having our tests in a separate module. Instead, we have to do something that is also referred to as white box testing, which means we somehow open up everything in our production module to our tests, although it normally isn't accessible from anywhere else. To support cases like this, which are usually not recommended for production code, the Java module system supports a concept called module patching. What it means is that you take an existing module that had already been compiled and compile additional classes into the module. So you basically extend an existing module with additional classes that can then see everything inside. If we would do this on the Java command line, we would add a number of arguments. One of them is a patch module argument that tells Java where the additional classes are, but you also need to tell it where the original compiled module is, and you might need additional options because the extended module might need to see more, so it has additional requires that were not defined in the original module info Java file, like the requirement for JUnit. And you not only need to add this patching arguments for the Java compiler, but also for the Java runtime, so that this relationship between different artifacts that are combined to one module is also known when the tests run. So this is tedious to configure, although you can configure arbitrary arguments for the compile task as well as for the test task. I won't do this here, but instead recommend also to use the Java module testing plugin. We can say that our test suite is white box, and the plugin will reconfigure the task with all the needed patching arguments. We can also define here which additional modules are required to run the tests, in our case the Jupyter API, and we can say that the module is opened, or certain parts of the module are opened up for reflection to certain other modules. The plugin will pass arguments to Java that open packages containing tests to the JUnit runtime, and then the runtime will find the tests via reflection. This all seems rather complicated at first, but on the other hand, you now clearly see what you need to do this kind of testing. You need to modify the original module with additional classes in order to have these test classes see internals. So strictly at test runtime, you test a different module than the one you use at production runtime. But this is not different to what is happening when you do testing on the class path. There also everything becomes visible to everything else, and you have additional things that are not there, so not visible at production runtime. So from this perspective, the module system test setup makes the potentially problematic things explicitly visible. In this video, I gave an overview of how the class path concept and the module path concept is used in testing Java projects. There are many aspects to this which are already covered in previous videos. I referred to them during this video, and they are also all linked in the description. Testing with the module path only becomes an issue once you start using the Java module system. Then at first, it is a bit tedious to get started, especially when you already have a project with existing tests that you need to keep running. The concept I showed, together with the Gradle X Java module testing plugin, gives you guidance on how to set this up. I hope you enjoyed my videos on Java modularity and learned some useful things. In the video description, I also linked to a complete project setup that combines all the concepts and plugins I showed in the modularity videos into one single project setup, both for a traditional Java project with multiple components that works with a class path, and a setup for Java modules that works with the Java module system and the module path for everything. If you enjoy my videos, please subscribe to this channel, and see you next time.